Hi, everyone. Welcome to my talk. Just an intro, I guess, is in order, in case you don't know me. Yeah, I am, my name is Zeeshan Ali Khan, and I'm generally an open source and Linux systems engineer. I'm pretty sure I'm less of a system engineer than most of you here, but yeah, that's what I do usually. And I'm from a bunch of different countries, and I have lived in different countries, and yeah, now I'm here. And one of the things people know about me is that I'm into Rust, and this talk is going to be around Rust. Surprise, surprise. But yeah, before we talk about like optimization, let me just give you a brief overview of as what zbus is. It's basically a pure Rust dbus library. And what you might be wondering, what the hell is dbus? I don't know if you are, because you're in this room. So can you raise hand if you don't know what dbus is? Oh my God, everyone knows. That's good. Usually I have to introduce it in every conference, but good that I don't have to do it here. But before zbus, if you wanted to do any kind of dbus code or service or anything in Rust, you had to use another library called dbus, or more like dbus rs, because dbus is the name of the protocol. It was basically a libdbus wrapper. And if libdbus, if you code in C and you have ever done any dbus, you would know that you don't want to use libdbus. It's not a nice API. I don't think I have ever met anyone who would want to use it in the last 20 years. And it had also multiple issues. Like overall, it was like a wrapper, right? So it can't really make it that good, the API, because it's just a wrapper in the end. So I came up with the idea of creating a new API for Rust that would be pure Rust, so that we are not like bound by the C limitations and archaic practices, and we can do something modern, something nice, something easy to use. So zbus was born, and we even have a cool animation for this as an illustration. That's done by someone called Jakob Steiner, which probably some of you know who that is. Yeah, so it became the go-to dbus crate in the Rust world after that. There was actually, when I announced about zbus work, a bunch of them popped up, like everyone decided, oh, I can do better, I can do better. And as I thought, they all died out, like not a single one of them survived. So zbus was the only one remaining. So nowadays you only have a choice between zbus and dbus rs. And I don't know what would be the reason to use dbus rs, but you can use it if you want. But yeah, and there was a lot of praise, and everyone was happy about it, that this is cool, this is easy to use, awesome. So yeah, we might be wondering, what is the problem then if it's so good? Before we go there, I'll have to introduce part of zbus called zvariant, which came first, because I have like this bottoms-up approach. I try to first get the foundations right. So zvariant is the subcrate sublibrary, or however you call it, that is responsible for encoding and decoding the payload, the message format. So that's something that came first, and it's Serde based since the version 2.0. Serde is a library, a framework in the Rust world, if you don't know, which makes serialization, deserialization super easy. It's really nice to use, and actually one of the biggest point of it is that it decouples this the specific deserialization and serialization to specific formats, and you making your types serializable or deserializable. So it completely decouples it. So you can make your type, like you can say that, oh, I want this type to be serialized as an integer or an array of integers or any complex type, right? But you don't need to think about the exact format it will be in, and then you can just use it with, for example, Saturday JSON, which does it JSON encoding, decoding, and then zvariant, for example, for dbus encoding, and also zvariant supports this format called gvariant. So that also is supported, so you can do that too. So it completely decouples it, and that's one of its big strengths. But unfortunately, there were some fundamental incompatibilities between Saturday and also in Rust in general and dbus format. And some of them, I guess, is because when it was created, mostly it was about C and C++ folks, not they didn't think about the future, how things are going to be. But some of them are a bit fundamental, and I was a bit surprised, like, why didn't they think about this? In Rust world, you have a type called option T, which is anything that is nullable, anything that is optional, basically, as the name suggests. It's a generic, so you can use it with anything. And people use that a lot for all the other formats with Saturday and serialization, deserialization. And I don't blame them. It's very convenient, and you need this concept in this case. So, but there's no nullable types in dbus world. We have a sort of a hack, which is to encode it as an empty array. If it's a none. If it's some, then one element array. But it's still a hack. Gvariant format solved that problem, but gvariant is not the main thing we use for IPC. Unfortunately, it never became the thing. So it was, I think it was supposed to be dbus 2.0. Alison was here, but I think she left because she didn't want to answer this question. So yeah, she made gvariant. Anyway, so one of the other problems was empty array alignment. That was a much bigger problem because you are in this conference, so I'm pretty sure you know what alignment is all about, but just in case you don't know, you can go to this Wikipedia article, and it can explain to you very well what alignment is all about in serializing binary formats. And the problem was that in dbus world, in dbus, the empty array has to be encoded such that there is padding needed for even an empty array. So even if there is no element, you need to have padding for the element, which does not exist. And that makes things very difficult because of how Saturday API is, like how you need to implement your serializer. So here, let's say you're implementing a serializer, you will say you will declare a few types, and one of them is what type to use for serializing a sequence. A sequence is array in this case, and the function implementation which does the serialization, which starts it, and it returns the actual sequence serializer. And the sequence serializer is you can also implement it for your type, and in that one you have a function method to be called for each element and the end of it. So they would only do these two things. But as the comment suggests here, if the array is empty, this will never be called because there is no element to encode. So how do I add padding for the type, because I don't know anything about the type, and the padding of a type is dependent on what that type is. If it's being encoded as an integer, as an array, so all those types have completely different padding requirements, right? So it's impossible to do it in the generic way that Saturday is designed for. So how did I solve it? Enter dbus type signatures. So dbus has a mechanism to describe a format, an encoding. So what is inside this binary message body actually. So you can have, like, for example, this one is struct with integer boolean array of string, which is actually a dictionary in dbus. So you can describe very complex types actually. All the types that are encodable by dbus is describable. So I came up with the idea of a type crate that specifies for each type that you want to encode and decode. In addition to implementing serialize and or deserialize, you also implement now another trait called type, which gives us the signature. So our deserializer and deserializer knows what type is being encoded at any specific time. The main thing is type, and dynamic type is just like if it's a dynamic thing which you don't know in advance what the type is. But it's not that nice, because it sort of beats one of the main advantages of SERDE, so that your serializer and deserializer is completely separate from your type being serializable and deserializable. You have to now implement yet another trait, which is very annoying. But I tried to make it as easy as possible, so I provided also a derive. In Rust world, derive is just like you derive something on your type, and then that trait is implemented for you based on what's inside your type. So it only works for, of course, complex types like struct and enum, but it's possible. So this makes it much easier, but still it's like sort of beating the point, but not so much. And also to make it even more easier, I also provided implementations for commonly used types. Since SERDE is so common in the Rust world, everyone provides serialized and deserialized implementation for their types and all their crates. So their SERDE support is usually already provided by the crates themselves. But we are not that famous, so nobody would provide dbus types for their dbus implementation for their types. So we had to do it. So in zvariant, there's a lot of features that you can enable to add support for various commonly used libraries, for example, and all the standard types from standard library as well implemented. So including external crates like chrono, UID, these are like very commonly used type crates in the Rust world. And it also meant like too many allocations, because each time we need a signature from a type, we ask it like, give me your signature. We can maybe cache it, but still it's like at least allocating once at the very least, and copying the string and then serializing it. So that's a lot of allocations in a lot of cases. And it's not const. So in Rust world, we have a const keyword. It means a bit differently than C, but it's similar. So yeah, if you can make it const anything, then it becomes compile time thing, which is always best. What about performance? Like maybe we should look at the performance of how it actually is like, instead of just wondering about it. Fortunately, one of the people who created the Rust crates that I mentioned, that sort of died out after a while, their nick is Killing Spark. I don't know what that means, but that's their nick. Killing Spark created this comparison of all these different crates, which uses something called Cargo Bench. It is like a benchmarking framework built into Cargo, the build system in Rust. And also you can use it with different kind of benchmarking frameworks, like Criterion is the most common one. And they found out this. I'm not going to list all the implementations, since they didn't go anywhere, but only the ones that actually use. So dbus RS was sort of like in most ways either better or similar. So this was like, this is not really giving us much. So as you can see, like in some cases it is better, but it could be much better, because the libdbus is not famous for its performance, right? So how can we? We were like, okay, yeah, it's okay. We can we can live with this, and the bar is low, so whatever. Like, let's go. But I did figure out like what was the biggest bottleneck, right? Like I was like, what if I ever want to optimize it further? What would be the bottleneck that I need to first address? For that, I need to introduce something called flame graph, which is a really nice tool, and you can use it with cargo, and you can create some sort of benchmarks, and then you can flame graph them, and then you create something like this. The creators of this whole thing, they were not into colors, I'm guessing, because color-wise, it's really bad, but yeah, it does its job. So what we found out was signature parsing was the biggest problem, and it's because like you're representing it as a string, like we are representing as a string, and string parsing like each time, especially with the arrays, right? Like especially with large arrays, you do it for each element every time, even though it's the same type. Like in an array, the type would be the same. So we are parsing it for no reason at all. And I spent many sleepless nights, and I was thinking like, what could I do about it? But it wasn't like nothing came to mind like how with the current Rust work. It's hard. And years went by. Sometimes I would think about it, and then I encountered something called postcard and postcard RPC, which is like used in the embedded Rust world, bare metal world, to communicate between a microcontroller and a host. So it's designed to be quite efficient. And they gave me some idea, right? Like they had something similar to a signature or a type trait, which provides a signature for your type. And it was all const. It was all static, and I realized that, oh, why didn't I use already parsed format for the signature, and then I can make it const. So I was like, this is exactly what I need. So I rethought the signature representation, and it became this. So you have enum that represents all the types, and then you have complex types. And then in that one you have a child type, and the child type could be either static or dynamic. So in case of dynamic, you can just use a heap allocation, but instead of static, you can use completely static and const. So all of these types are now completely const. And then the trait also now provides you, instead of method, you get a const, and then at const time you can tell your type what type it is, and we don't need to parse it as part of serialize or deserialize anymore. So deserializer don't parse anymore? Well, mostly yes, but not 100%. So we have variants, which is a dynamic type in dbus. I'm hoping that you know what that is because I'm going out of time, it seems. But that cannot be helped. Like it's a dynamic type, so you get the signature at runtime. So you cannot have a representation ready at compile time for it. So that, since it cannot be helped, what we can do at least is like very robust and efficient parsers for the encoder decoder of the signature, and that would solve it as much as it's humanly possible, right? And we use the library called nom, but now there's a replacement called vnow, which is much more efficient. It's like now using the parser of the signature is now using this. So it also had, so it only parses once at least. So that's great. And best of all, it just worked. I was so happy when I saw. But how does it perform? Like, it works, but does it help? And voila, this became so much more efficient. It was just incredible to see those numbers. So the 0 and 3 is where I didn't have any optimization. The number 5 is where I had all the optimization done. And this is such a big difference, and it's something to be celebrated. But as promised, 95%. And if you are really good at calculating, you would have seen that the best one was 90%, not 95%. But the thing is, you have to keep in mind that I benchmarked on my sort of a high-end machine. So but I also asked other people to do some benchmarking for me on their low-end machines, and that was 95%, and maybe even more at some point. It was at for some things it was 96% even. So it depends on your hardware. Basically, and also it depends on the type. So the fixed size arrays it became extremely efficient, like almost close to 100%. So that's quite amazing. Yeah, but in future, what can we do about more optimizations? Well, we can do micro optimizations basically. Because I think we have hit our limit. How far we can go with optimizations and other improvements. And the thing is that a few are already in. After I did all my signature parsing optimizations and stuff, and one of them was from someone called Tate Hoyam, and another one was from Emilio. They both added more optimizations, and in some cases it became like really they were, I would call them micro optimization, not because they were small optimization, they were really huge optimizations, but they were for specific cases. So if you want to, let's say, read a header from a dbus message quite often, then Tate's optimization was like 90 to 95%, even on top of what we already had. So that was amazing. But what is the future of IPC? And I think that's Warlink, something called Warlink. You might have heard of it if you're here. But for that, you have to come to my other talk about that. But the thing is that dbus is not going away anytime soon. You will still want to use zbus, and if you use it, then it's super optimized now. If you find other avenues for optimizations, be my guest. I'm always happy to receive contributions. But I think it's not there's not a lot of optimizations you can put in anymore. But yeah, it's going to be around, and you have zbus library for using that and for doing dbus, any kind of dbus stuff in Rust. And it will, yeah, just remain as legacy dbus, in my opinion. But let's see how long till. Yeah. Sorry, I had to go so fast because I was told like it's 5 minutes left. And,
we have like 2 minutes, so maybe 1 or 2 questions. No questions.
Oh, wow. I explained everything so well, or did I explain so horribly that nobody come up with a good... Oh, there's one.
Ah.
What does the testing setup look like? Is it synthetic, or do you have real-world use cases for measuring performance here?
It's the encoding, decoding. In some of these cases, it's like also sending and receiving is all part of it, like the whole pipeline. Where did it go? In here, I forgot to mention this NAND thing. So when we put all of that together, the zvariant 5 was so fast that all those connections were made too fast. And it was just giving us an error, like the dbus broker was kicking us out. So we couldn't measure that whole pipeline, complete pipeline for zvariant 5. So it became a bit too fast. But yeah, so it was the whole pipeline, and that's the part we couldn't measure because the way test was designed, it was creating new connections all the time, and that's in dbus that's a bit problematic. So yeah, someday maybe I'll redesign it to not do that, but right now it's how it is.
Okay, thank you very much again.
No worries.